Okay, let's get started. Good morning. So in this session, we are going to learn how to create a PHP library the right way. My name is Christian Varela, and here is my Twitter information at Gabriel0702, or you can contact me via email, cvarela@conquerorsoft.com. And finally, that's the URL for joined in, so you can give me feedback and rate the talk and let me know how can I do better in the future. It is highly recommended that you go to the slides if you want to follow along. So you can go to SlideShare/Christian Varela 5, create a PHP library the right way. The slides are also in joined in already. So ready? Yeah? No? Okay. Just a few seconds. Okay, let's move on. So there are also some requirements. If you want to fully follow along this, so you can go to this page and it is going to exactly tell you what do you need for the library. It is just nothing difficult. It's just like a composer, install on your computer, a couple of repositories, and that's it. So you can go and take a look at those requirements also. And I think we can start then. So my name is Christian Varela. Also before, sorry, if you don't have internet connection or something or anything, I put 3 pen drives here. You can take the information from there and return it so everybody can have that information in case you missed the URL or whatever. So my name is Christian Varela. I have a wife and 3 daughters. I am originally from Mexico, but I've been living in Miami since 2008. I have a master's degree in computer science. I created my own company, Conqueror Soft, which is basically software development for companies. And I like to play guitar and piano. This is my family. My wife, my oldest daughter, the one in the middle, and the youngest one. And I am here. Maybe you don't recognize me because I am now with, but it is me. So Conqueror Soft will take your business to the next level. You can visit us at www.conquerorsoft.com or send us an email at info@conquerorsoft.com or visit our Facebook page. These are the main technologies we work with. And we support software, either if it is using platforms or just like customized software for the companies. So what is this session about? So I'm going to start by asking a question. How many of you have found in a situation where you have developed something that you are going to need in another project and you need to copy, paste, and adapt that piece of software? So many of us, right? So I've been in that situation also. And it is like strange because one of the first things that we learn as software developers is like don't repeat ourselves. So it helps us in the future to have a more maintainable software. So in this session, you are going to get rid of that practice of copy and pasting and start developing for the future, for yourself and for your team and If you want to welcome contributors to your the pieces of software that you are developing, you can do that too. So you are going to be guided in this tutorial about the steps that you can follow when creating a library. That way you are going to have a best maintainability for your software. So what is a library then? A software library is going to be a collection of methods or functionalities or classes or anything that can be encapsulated and that you can take and easily use it in another project, or other projects that you don't own can use that piece of functionality too. It's independent enough to be integrated as a functional block, so you can just plug it in a project or unplug it and be part of that project. And it could be used by systems that don't have any connection among them. So like as I was saying, if you are trying to have a library that you think it is going to help others, you can do that too. So libraries or packages is just like Lego blocks that you can put them together in order to build something that it is going to be on the same alignment of purposes, but you have that functionality encapsulated in that block and not merged all along. Why should you create libraries? Because they provide reusability. You wouldn't need to copy, paste, and adapt. Instead, you would like just have that library and require that library in your project that you are going to use it. They could help open source. Like, for example, if you are facing a new development and you think it could help not only you but other companies in the industry, you could develop a open source library. They are modular in functionality context, so they have its own functionality, logic, and everything that could be then wired to a system, and they are easier to maintain than having like all along software. So web application is a web application running in the web, which is going to provide a solution to a particular problem. The application can have modules, programs, configuration files, connected and related. Each piece has its purpose. So the goal is to have like a solution for a common goal. They are served by a server, requested by a user through the browser. They can interact with a database. They can use third-party libraries or packages, use private packages, the ones that you can develop, and they have configuration files. So it is like this. You have a user requesting a page or a resource. It comes over internet, and you have the web application here. So the web server, the application server, the database, the internal dependencies. Dependencies is another name for the libraries, is the piece of software that you need for your application to work. So you can have internal dependencies, external dependencies, and configuration files. So most of us are familiar with this. As I was saying, this is like something that we can build using like Lego blocks in order to build like a system like this in this case, right? Like you can have different pieces that it is going to build a bigger system with a common purpose. So now we have the basic concepts. We know what a package or a library is, the web application. So now how the web application knows about its dependencies. So we have the web application. We can have all these components, and the web application can say, where, okay, I have these needs, but where are my dependencies? So for that, we have Composer, and Composer handles those dependencies using Composer JSON. How many of you are familiar with Composer? Okay, most of us. So it's a dependency manager. What it is going to do is it is going to handle the dependencies for your application. In this case, we are going to see both approaches, like from a application perspective and from a library perspective. So it's a tool that is going to handle your dependencies in PHP. it allows to declare the libraries and the packages that you are going to need for your project, and it is going to install them or update them for you. It enables you to declare those in the composer.json file. It finds which version of the packages can be installed for you, and you have those requirements in your project. It does that through the composer.json file. So it's there where you would need to define your dependencies. Even when you are creating a library or a package, you are going to have some dependencies, so you are going to use that file even while creating the library. And there are two key keys for the composer.json file, which is the require and the repositories. In the require section, you would specify which libraries you are going to be depending on for your project to work. And you would specify like the name of the library and the version that you want to install in your application. And in the repositories key, you would specify where to find those packages. So you would define what you need and where to find those packages. So here are the most popular keys for the file. We have the name, the description. That's just so the consumers of your libraries can know exactly what your library is going to do. Type, in this case, we have several types, but we are going to be focusing only on project type, which is like an application, and library type, which is what we are going to develop here. We have keywords into the composer.json file, so whatever is looking for our package has like an extra way to search for those packages. Homepage, if we maintain a separate homepage for the library. Authors, support, like who is supporting that library, the contact information and everything. Require would be the packages that we need for our library to work in a production environment. Require dev would be for anything that we need that it is not required in the production environment, but it is like something that we need for the development, like, for example, test tools. We have suggest, like, for example, if we are providing a library that may work with another library, we can say, okay, we suggest to install this other library. Autoload is going to be providing a way for our, let's say, development, either if it is project or library, to have a way to be auto-loaded when it is required. Auto-load dev, that's for the libraries that we would have in required dev. Repositories, you would specify where to get the libraries that you are needing. And scripts, there are a lot more keys, but these are the most popular. Scripts, you would have a way to define like programs that you want to run either for your vendor libraries, like for example, if you are using PHP unit, which is used to do test, you could have a script that it would be handled by Composer. Like for example, instead of running PHP unit or PHP unit.var, you could run it instead like a Composer test, and you would have that definition in the script section. So as we were saying, where Composer get the packages from. So we tell our application, we define our Composer.json file, we specify everything that we need, so next what? So Composer is going to ask where to get those packages from, right? And we have several ways to get those packages. First, we have packages.org, which is like a list of all the packages that are available for all the persons that submit their packages in packages.org. That's for open source, let's say, libraries or projects, because they are available for use. For the private packages or anything that it is not like for open source, you have packages.com, which is, it works the same way. The only difference is that one is for public projects and the only is for private. But you also have a an extra option, which is custom repositories. Like if you don't want to host, for example, your libraries in either of these platforms, you could have a private repository, or even if it is like something more customized, you could have something hosted in Git, in Fossil, or SVN, which are version control systems. And you could define the path to find those packages, either if they are locally in your computer or your network system, or if they are hosted like in a SVN hosted solution like GitHub or Bitbucket or any other. So packages.org is going to have it is a Composer repository, and it's the main Composer repository for Composer. It's basically a source of packages. It is going to have a list of all the packages that are hosted there. You can automatically require any package that it is listed in packages, and you don't need to specify any other configuration in the Composer JSON file. So what I mean is, if you have a package that it is listed on packages.org, you don't need to define the repository section on the Composer JSON file. Packages.com, it's the same Composer repository. This would be for private packages, commercial packages. It is not only that they offer like, okay, you don't want your package to be public, hosted with us. It also offers other advantages, like for example, they have a mirroring for your packages. So if you host your package in GitHub and it is private, and you have it in packages.com, even if GitHub goes offline, you have the options to still have your packages available because you have those packages mirrored in packages.com. And finally, you have the custom repositories from different version control systems. As I was saying, you can have them locally or in your local network reachable, or you could have it hosted in GitHub or Bitbucket or any other hosted solution. The only thing is that if you have those hosted in GitHub or Bitbucket, you would need to provide the credentials, the appropriate credentials to access those repositories. So there are several types of custom repositories. Composer is like in the same way that Composer JSON is used to require the packages, and you could use any network connection like HTTP or FTP or SSH, or even file system. It would contain a list of all the libraries that you are available to offer through that particular resource, and it is just provided through a PHP stream. So you could configure extra options to that stream using the options parameters in the Composer JSON file. Also, we have the version control system type, which is, in this case, you would specify something from Git, SVN, or Fossil, or other kind of version control systems, and the location of that. Also, you could use packages from PER. And finally, there is another less used option, which is package. If you have some code that it is not in a version control system and it doesn't have any kind of version control or anything, it's just something that you need to provide, you would have the options to provide that through package, and they could be even like zip files or just raw code. Also, you can specify which packages you need from the platform. Like, for example, you could say, my library requires PHP version 7, for example. Composer is not going to install these kind of packages. It's just for your library to avoid having a runtime issue. Like, for example, if you want to install a library in a project and you don't have the requirements, like, for example, for PHP or something, Composer is going to give you a warning about the requirements that your library has. So if you develop your library to be compatible with PHP 7 only, when Composer tries to install that library in a version, in a different version, it's going to give you a warning and not to wait for a runtime error. You can specify which PHP extensions you need for your library, like for example GD, or any PHP native library like Curl, or I mean not native library, any library that you would need for the system. So you can require that also in the, define that in the composer JSON file. It is important that you provide a way for your classes to be autoloaded, so whenever it is required, the project is going to have a way to load those libraries. What Composer does is it takes, your library has to be in PSR4 format, which is PHP standard recommendation. And that way you can provide a way for Composer to take your classes and put them in a special file, which is autoload PHP under vendor directory. And then your application can have access to your libraries. So this file, autoload PHP, is regenerated every time that Composer does install, update, or Composer dump autoload. So as I was saying, PSR4 is PHP standard recommendation. This talks about the format that you can specify while you are developing your application, like certain conventions that you can have in order for your library or your project to be autoloaded. And the intention is to have like the libraries in a way that they can be interacting with each other or with the project in a standard way. And it also describes where to put the files according to that specification. So when you are developing libraries or projects, you need to consider packages versioning. When I started developing PHP, this is something that I never took in consideration. I started developing in C, Portland Turbo C. Then I went to Visual Basic. And in Visual Basic, there was always, like, whenever you started a project, you have like the version of the project that you wanted to start, and you had control of the versioning. When I moved to PHP, it is not like blaming PHP, because obviously we are the ones developing this, right? But when I started developing that, I never considered versioning. When you are starting developing libraries or projects, in this case most focused on libraries, you need to consider versioning, because that way you are going to provide the consumers of your library a way to know where is happening on each version, and you are also standardized the way that you are developing that. So for versioning, when you are developing using Composer, they could be handled manually in Composer JSON. So if you are creating a library, you can specify in the Composer JSON, okay, this is version 1.00, which is not recommended, because obviously you would have to maintain that each time that you create a new functionality for your library. The best way to do this is by version control systems. Like you would have the option to use that by branches or by tags. Like, for example, you just have a commit, so you can assign a tag to that commit saying, okay, this particular commit is this version. Or you could do it by branches. Like, for example, if you are currently on branch 100, you can create, I mean, you are on version 100, you can create a new branch 101, and then that would be taken by Composer automatically. You need to define a consistent version standard. So the recommended is semantic version. There are other ways to create your versioning convention, or you can define your own. But semantic version is like a very, very useful. You could go to semver.org, and you are going to have all the details there. But we are going to at least define a little bit about that later. This is when you are developing. You need to provide a version to your library so others can know exactly what is happening on your development. Now, when you are installing dependencies, because you are going to need these also, as I was saying, for your project or your library, you need to define which versions of the packages you are going to need. So there are several version constraints that you can use. You could say, for example, okay, I need PHP unit 5.6.3, for example, so be explicit on that. Or you could define a range, like put in greater than or equal 2.0, for example, and less than 3.0. You could use the hyphen. Sorry. When you use hyphen, it is like inclusive. So you would have greater or equal than, or less than or equal than. With wildcard, it is very similar. It would be like greater than or equal but less. With tilde, you would specify like with tilde and caret, you would specify like a minimum version that you need for your library or your project. So it would not break functionality. Both of them won't break functionality with the next version. So it is going to have more sense if we see the semantic version. So the way semantic version standard is, it has like a 3-layer of versions. It has the major, the minor, and the patch. And you, every time that you do a change on your library, you need to update this version. So major version would be updated only if you are providing a new functionality or you are changing something that it is not going to be compatible, backward compatible. So you would increase major in that case. Minor would be increased if you have something that you are changing or adding, but that it is backward compatible with your current version. And finally, patch would be increased when you have like a very, let's say, insignificant changes, like maybe you are changing the legend of a message or something, or when you are applying fixes and they are going to be backwards compatible. So if you follow that convention, then you can have that constraint in the composer, as I was saying. Like, for example, with the example number 6, when we provide the caret, it would go to from greater or equal than that version, but not to the one that introduces any like incompatible change. So that way you make sure that your project is going to have always the libraries that you need, but without breaking functionality. Also, another super important thing that you need for your library is the licensing, because if you don't provide a license, it could be taken as proprietary software, which cannot be used at all, and it cannot be like a shared or anything. It could be the case, but if that's the case, you should explicitly specify that your code is not open to be distributed and everything. So if you need to choose the license that you want, there is one site called choosealicense.com, and basically it has these categories that they think your library is going to fall under one of these 3. Like, if you want your library to be simple and permissive, there is this MIT license. Obviously, you are going to have more information, right? Because it is not like just these 3. There is like a lot of license, but these are like the main ones. So if you are concerned about patents, it is like a MIT license. It's similar to that, but you are granting use of those patents also. Or if you care about shared improvements, you would have like the GPL license. But as I was saying, there is a lot more license. If you go to choose a license, it will guide you through the process, like the conditions that you want for your library. So there is another thing that you need to consider, which is minimum stability for your dependencies and your libraries, both when you provide that stability as the development of your library, or when you are requiring libraries from a third party. So for example, there could be libraries that you need for your application, but they are not stable. So it wouldn't be that right to use a non-stable library, for example, on your production environment, right? So you could define the minimum stability for your library. So when Composer goes and look for the libraries that you need, it is going to verify that stability for that. So these are the stability levels, like you have dev, alpha, beta, release candidate, or stable. And another thing super important that you need to consider when you are developing your library is the code quality. So it is like a subject difficult to, well, not that difficult, but difficult to discuss, because one thing that it is code quality for you is not going to be necessarily code quality for another person, right? So for that, you could use instead of having opinions and that, you could use like a standard. There is a standard PSR2, PHP recommendations, standard recommendation, which is like a guide of coding practices. It extends another PHP recommendation, which is PSR1. PSR1 is for the basic coding standards, and the PSR2 extend those to more options, like they have rules, like for example, where to use curly braces on the same line, where they can be used on different lines, if you need to use tabs or spaces and that. So the goal is to reduce those frictions that could be in a team or whatever. If the team agrees to use PSR2, then all of them are going to be on the same page. And it is most probably that if you are going to have contributors, those contributors are going to be familiar with this standard too. There are tools like a PHP code sniffer that helps you to comply with those standards. So for example, you can have PHP code sniffer, which is a set of two scripts. There is one that verifies and the other that fixes. And you can say, okay, PHP code sniffer, I want to use this PSR2 standard. Please review my code. It will review your code and it will tell you, no, you are not complying with this in this line. You need to do this. And you can do manually the fix, or you could use the other script, which is PHP CBF, and say, okay, fix all of those for me. So it will go to your code, modify everything, and you are now compliant with PSR2 standard. Another important thing that you need to consider when you are developing the library is a change log file. So whenever you are introducing a change to your library, it needs to be somewhere. So some people have said, okay, it's somewhere. It's in one place. It is on my commit in the version control system. But that doesn't guarantee that your commits are like a fully explicit or what exactly is being done there. Also, you have like you could have merges of branches or anything that it is going to break the let's say the real order of the library. So that's not like a very trusted way to say, okay, my changes can be on the version control system and go there and find out, because that's not going to be like a very friendly for all the users of your library. So in order to have a change log file, you are going to have like an order list of all your changes, and you are going to need exactly what is happening in each version. Are you familiar with changelog files? Like, have you read changelog files from libraries? Okay, so it is basically you need to specifically know what's happening. Like, for example, if you are having issues with a third-party library, you can go and see what is the new features of something that it is causing an issue for you if you have on certain version. So this is providing the same for the consumers of your library. The contributors also would see exactly what is happening on your library or project. And there are some rules that you need to consider when having a changelog file. There should be an entry for every single version that you have in your library. The same types of changes should be grouped. Like, for example, if you are adding 5 features, those should be under the added section, or changed under the change section. The versions and sections should be linkable. And this is not something like written on rock, but this is like something that it is useful to provide. The version and the section should be linkable. For example, the latest version comes first, so that's the first version, the first version that you're going to see on the list. And also the date it was released. Like, for example, you are putting then version 1.0.0 was released on this date, and this was what changed. Semantic version as versioning is the recommended, but as I was saying, you can choose any specification for versioning. So these are the sections that you would have on the changelog, like added for new features, changed for everything that was already existent functionality, deprecated. This is not for something that you already removed. This would be for something that it is going to be removed shortly. So you have then removed. So the practice here is that if you plan to deprecate some functionality, you would release a version with deprecated, and then you would release another version with removed, for that particular transition. Fixed for any bug that you fix, and security for any particular vulnerability that you solved or something. So another important subject when you are developing your PHP library is have continuous integration tools. They are going to help you having automation for your library. Like, for example, if you are developing and you are testing, instead of having to test or deploy manually each time that you are going to promote something, you can use continuous integration tools, and they can be very flexible for the steps that you want to consider. Like, for example, if you want to consider automation of test, you can have it there. Or if you want scans, like static code scans or something, you can have them there, and you can incorporate deployments in the continuous integration tools also. So there is a couple of tools that I am going to present here. We have Travis continuous integration. You would need to have a way to connect to Travis. So in this case, you can have GitHub linked to Travis. Your project would be hosted as a repository on GitHub, and your working code is at your project. You have the working build or test functionality in the tool, and it has also 2 options, the .org for public repositories. If your project is open source, you can use it completely without any kind of pricing. And Travis continuous integration .com would be for private repositories. So you would sign into Travis using a GitHub account, linking those. You would select the GitHub repositories that you want to activate there. You would need a Travis YML file configuration, so Travis know exactly what you expect from it. And once you have that, every time that you do a push to trigger every time that you do a push, it will trigger a build on the Travis site. You can check the build status on their platform, on the page, and you would have the GitHub account configuration with that webhook service. This is another tool, Scrutinizer. It is very similar, but it offers a couple of different services. But it would be very similar, the process. You would have a GitHub repository. You would add a configuration file for it. Every time that you do a push, is going to trigger a build. And you can verify the status of the build in their page. And you will have also the webhook on your GitHub account. So how Composer handles the library's installation an upgrade for those. We have two main commands for Composer. One is Composer install. So whenever you call Composer install, this is what is going to happen on your project. It is going to verify if you have a Composer JSON file, because that's the first requirement it needs. If you don't have it, you are going to have an error. If you have it, it is going to verify if Composer log exists. If it doesn't, it is going to install the libraries that are defined in the Composer JSON file. So it is going to look for those libraries, the version constraints. It is going to get them, install them, and then it is going to generate Composer log file. So this Composer log file is like a fingerprint of the packages that you installed and the versions available at that moment for your project. If there is a Composer log file, it is going to compare Composer JSON against Composer log to see that everything is matching. If they don't match, then you are going to have an error, and you would need to run Composer update, which is the one that we are going to see. If they match, then it is going to install the libraries from Composer log. And match, it doesn't mean that it is going to compare it one against the other. It's just going to compare the libraries and the versions that you have in those files. When you do Composer update, it's going to be similar, but it has a couple of differences. It is going to verify Composer JSON. If it doesn't exist, it's going to do an error. If Composer log doesn't exist, it's going to install the libraries, because there is no any library yet there, from Composer JSON, and it is going to generate Composer log. If the files match, I mean, if there is Composer log and the files don't match, you are going to have an error. If the files match, then it is going to install the most recent version of the libraries that comply with the version constraint that you have. So for example, if you when you created your project, let's say in January, and you required PHP unit, and the version at that time was 5.7.1, and you do Composer update today, since you want like a minimum version 5.7, at that time it was 5.7.1, and now it could be 5.7.6. So it would take that new version and it would install it, and then it would update Composer log file. So another important thing to know here is that for your projects, you want to include the Composer log file into your version control system, so the consumers of your project or the users of your project can know exactly that they are going to have a fully functional, let's say, version of the system. And for the libraries, it is not like used to submit Composer log to the version control system. And that's just a convention, because in the library you have a more dynamic development cycle, let's say, and you want more flexibility for that. But it is up to you. If your library is like not having those amount of changes, you can commit it into your version control system. So let's go to the funny part, which is actually creating a library using Composer. So let's do this. So I'm going to have mirror displays here. Optimize for this. So this is what we are going to do. So what we are going to do is we are going to create a Composer JSON file. We are going to do this manually in this exercise. So a second. I think my computer is... Yeah. So we are going to create a folder, PHP library, exercise 1. We are going to go to that exercise folder, and we are going to create a composer JSON file. Composer has a tool which is validate. It is going to allow you to review your composer file for any error. So it is like a good practice to run composer validate whenever you are creating a file for your application. So what I'm going to do, I'm going to do this with you. I'm going to put this in the left part of the screen. It is like a visible enough or not? Yes. So I am going to open a new terminal. I'm going to put this on the left part of the screen, and I'm going to do the same. I'm just going to copy from here. cd PHP library exercise 1. I'm sorry. So we are on exercise 1. We don't have anything there yet. So let's just create composer JSON. If I am too fast or you need to interrupt me at any moment, just don't hesitate to do it. So I'm going to have that composer JSON file, and I'm going to open my editor here. Let me go back here. And I'm going to my directory that I just created here. So here is our composer JSON file. So okay, everyone is done with that. Okay, let's then provide these values to our composer JSON file. So instead of PHP library right way with underscores, put your GitHub user and / exercise 1. Right now it doesn't have any relevance, but you wouldn't put PHP library right way. It's just put your GitHub user. I'm going to put this on the right part of the screen. And I'm going to start by opening curly braces. And this is JSON format, so we would have a double quotes name, double quotes colon, and the name, like I am going to use this user for me. Then after we start a property, we add the comma, and let me... The what? Oh, yes, no, go ahead. I don't know where they are turned off, but yes, you can go ahead. Yeah? Okay. So we have the name, then the description. And if you finish first than me, and just like be patient with me, creating a composer JSON file manually. So comma for this. Then the next we would have the required section. For this we are going to have, since this is a section, we would open another curly braces, and we would define the properties here. Like for example, I want this library to have PHP version. We are going to have minimum version 5.6 or minimum version 7.0, and that's for the required section. So we would go to the require dev, and we would put PHP unit / PHP unit, and the version, which would be minimum 5.7. And I just put that because while I was preparing this repository for this session, I realized that I required the last version, and the last version was not compatible with PHP 5.6. So now I know that you should use 5.7. So that's the required section. Then type, it would be library. And finally, license, MIT. So that's all the properties that we would define for our composer. And if I go to the terminal now, if I run composer validate, it's going to tell me, okay, your composer JSON is valid, so we are good. We have defined the libraries that we want for our library, the third-party libraries. So then I can run then composer install. We didn't define the repositories key on the composer JSON file because PHP unit is already on packages.org. So what composer install is going to do, it is going to go to packages.org. It is going to require that library, PHP unit, and it is going to also see which packages are required by PHP unit. So like in this case, all of these packages are required by that simple library. Those are automatically installed by Composer. And if we see now, we are going to see that we have the Composer JSON file that we had, Composer log file, which was created, and a vendor directory. So if we see what vendors has, it has all the libraries that we require. Like for example, it has Doctrine, PHP Documenter, PHP Spec, PHP Unit. All of those are libraries that are needed for our project. It is too small, or is good? I assume it's good. So all this was created under the vendor directory, and we have this autoload PHP file that our project can use for this particular library. Give me a second. So let me put my cell phones on. Okay. So that's our first exercise. Everyone was able to complete it? Perfect. So that's it. We have 1 hour. No, I'm kidding. So let's go to, let's move on with those. So these are the properties that we add to our Composer JSON file. It should be like this. So let's go to our exercise 2. So Composer also has a tool called Composer Init, which is very useful because you can now create your Composer JSON file using this tool instead of doing manually. So this is what we would do. We would create a PHP library /exercise2 directory. We would go to that directory, and instead of just manually creating the file, we are just putting Composer Init. We are going to run Composer Init. After we create that, we are going to validate and install the same way. So for Composer Init, we are going to provide these values to our exercise. Let me see if I can remove here. So it can be a little bit light on me. Yeah. So I'm going to do this with you. So let me go to the previous. Oh, sorry. View. side only, but navigation. So I'm going to copy from here. I'm going to create that. Go to PHP library exercise 2. So we don't have anything yet there, anything there yet. So composer init. And as you can see, it is going to guide you through the process to create the file. So the first thing it's going to ask is the package name. So I'm going to use Gabriel Conqueror, my Twitter, my GitHub account, exercise 2, exercise 2. That is going to be the package name, description, created with composer init. The author is going to take the information from your the one that you have registered on the computer. I am just going to have that as default. Minimum stability, I'm going to leave it as default, which is stable. Then package type, library, license, MIT. Now this is the part where you are going to define where your library is required. So would you like to define your dependencies, which each is on require interactively? Yes. Search for a package, PHP. Version, we would say caret 5.6 or caret 7.0 as minimum versions. Search for another package? No. Would you like to define your dev dependencies for required dev interactively? Yes. We would put PHP unit / PHP unit. Version, the one that we have here is minimum, defined with caret 5.7. And that's it for required dev. So it shows the JSON file for Composer. So we would say, do you confirm generation? Yes. If I go now to the, well, actually I'm not going to the code. This is like, you can see the file generated here. So if I do Composer validate, it's going to say that it is valid since it was created by Composer init and we provided the values. It is going to be valid. So after that, we can run Composer install. And it is going to do the same steps. It is going to go to look for the packages that we are requiring. It's going to install them. And it is going to generate the Composer log file and the vendor directory with all the options that we have. So that would be basically what we just did here. So it's 1 hour and we already developed 2 applications here. I mean, they don't do anything, but at least we have 2 of them right now. Yes, it works. What doesn't work is like if you try to do well, let me try to do something here. Yeah, exactly. Yeah, I tried to do that also. For example, let me see if I can do it again. Like, for example, I put that. It is not working here. But yes, I know what you are meaning because it puts like strange characters instead, right? Okay. Well, you can do at any point like Control-C and start over, and that wouldn't be that. Okay. So, okay, give me a second here. Just measuring the time. So far we are good. So that's the composer file. Basically, it is just the same, but we have let's say, a way to not commit any mistake. If we, for example, put an extra comma or don't put a comma for the sections, we can always look for composer in it for our projects. And there is another option that if you already have a composer JSON file and you want another library which is not currently part of your project, you could use composer require. And you would put, like, for example, composer require, and in this case you could put PHP unit, and the version, and composer is going to look for that library, get it, install it, and then update your composer log file. So exercise 3, creating my first functional library this time. So let's do that. So we are on time. Okay. These are the two repositories that we are going to use. If you already have them, or if you don't, go now and clone them. It is not absolutely necessarily, but it is good. On these repositories, what I did is in the README file, I put all the steps that we are going to follow in this session. So if you need to go them later, you can go and verify it. They have all the steps with the particular commands and the code, and everything is there, so you can go later. We have two because we are going to develop a library, but we are going to have a project that it is going to use that library. So we are going to the whole cycle. So exercise 3, I'm just going to copy from here also. I'm going to have this on the right. I'm going to copy this. We are going to create the PHP library, my first library folder, and we are going to create a README file. So the README file is going to be the file that is going to be the one that it is shown as default in the GitHub, or like what other, the Bitbucket or any repository online. So let me just create that file. Gabriel, PHP library, my first library. So I am going to create this file, which is going to be readme.md. MD because it is going to be on Markdown format. So is there anyone here that it is not familiar with Markdown? Okay, Markdown is a way to create text files in a certain format that can be converted to HTML format by a Markdown processor. So, for example, if we put just one single this symbol, and we put like my first library, and then we put like a description here. Let me go to this. So we are going to have the README file like on this side. This is my very first library I created at PHP World. So when we have this text format and we save this file this way, it is going to be converted to HTML. Like the first line would be converted to H1 tags, and this would be converted to regular paragraph in HTML. There is a lot other conventions like in Markdown. Also, another important thing what I did here is at the end of the slides I put resources that are going to have very useful information. One of those links is about Markdown, so you can go later to that page and see all the documentation about creating a library. So we have created our first library, and we have the README file. As I was saying, this is the first thing that the repository is going to show online. So let's see. It is very simple, but obviously this is something that you need to work on your library. You would specify what your library does, how it does it, how it can be used, how can you run tests for the libraries, and so on. This could be as extensive as you want. Obviously, you want to define like the minimum information that your users of the library need. So now we would go and create, initialize the GitHub, the Git repository for this. So let me go to PHP library, my first library. So far we have the README file, and let's do git init. Now we have a Git repository. Let's add everything. So far we just have the README file, and let's do our first commit. Excuse me? Yes, well, if you put it as exercise 3 is good, but actually it was my first library. But anyways, that's good. The location doesn't matter. I mean, as we on the same folder, don't worry about it. So we did our first commit. So what I usually used to do is just the commit and move on. And if I did something in the commit, as I was saying, I fell on that. I fell on that scenario where I said, what did I do on that date? Okay, let me go to the repository. So my workflow was like, okay, I need to know when was this done. I went to GitHub, network, insight, see the graph for that library, and then choose the commit, which is not that good. So instead of that, now what we should do is assign a version to that commit. So we do that by running this command git tag -a, the version that we need to specify, and we can provide optionally a message. Now, semantic version recommends. Yeah. Like that is good. So we would have this comment. We are providing a initial version. So -a adding, -m messaging, and the message that we have for that particular tag. The way it works, it is going to give a, let's say, more visual identification to your commit. We start with version 010 because that's the way semantic version recommends to start, like not with 001 but 010. And you can specify the version with the B suffix or without it. It's up to you, but at least you need to give that tag to your commit. So let's just do that. I'm going to copy and paste. And one important thing here is that tags are not automatically pushed to GitHub or to Bitbucket. You need to do a push for your tags every time that you create a new one. So this is our local repository. Let's go to GitHub. I'm going to open a new tab here. And I am going to create a new repository. Let me go to my repositories first. So my first library. I am just going to delete this so we are doing the same things, okay? So settings, delete this repository. Okay. Now, new repository, my first library. I'm going to provide the repository name and the description. This is a library example to be used on my session. So public. We are not going to create a README file, a gitignore file or a license right now. So just create the repository. And since we have that code already in our computer, we are just going to have this git remote add origin and the git push to origin master. And let's do that here. So it's done. So if I go now to my repo in GitHub, I am going to see my README file. So this is what I was talking about. Now we don't see the markdown format, we just see the conversion of that. So my first library, the title and the paragraph that we had. And if I go to the branch, I am just going to have the master branch, but I don't have any tag yet. As I was saying, we would need to push that in GitHub, so I would need to do git push origin and the name of the tag, in this case 010. So after that, if I go to the GitHub again, repository, I would see that tag there. Okay. So let's move on. So we created a repository in GitHub. We connect the repository with GitHub. This is just the steps that we just did. And that yellow there is weird. We copied that from GitHub because we had the existing repository in our computer. So now let's start with Composer. So let's do Composer init, and we are going to provide these values. So again, don't use PHP _ library right away. Use your GitHub account. So let's go to the terminal and git, yes? Yeah, you would need to go to git configuration. I don't remember the exact name of the configuration, but if you can help me on the audience, I think, yeah. Excuse me? It could be anywhere in the command line. It would be git config username, and you would put your name after that, and git config user email, right? User email. Yeah. Yeah, exactly. Exactly. So for those who didn't hear, you can use git config username, then you assign that git config user email and the email that you want to connect to GitHub, and dash dash global if you want that for like all your projects for Git in your computer. So let's do composer init, and we would provide these values. Like for example, in my case, I'm going to put my GitHub user, Gabriel Conqueror / my first library, description created with composer init, or any description that you want to put. The author, I'm going to leave it as it is right now. Minimum stability default, which is going to be stable. Package type library. License MIT. The dependencies for require, yes. PHP. The latest, no, not the latest version. The minimum version 5.6 or minimum version 7.0, and that's for the require. Now require dev PHP unit / PHP unit minimum version 5.7. I'm sorry. I should reply yes, not that. Require dev, yes. Search for package PHP unit. PHP unit. Now minimum version 5.7. And let's see, we have the require PHP. Everything seems good. Yes. Would you like the vendor directory added to your git ignore? Yes. And composer validate. Is good. Composer install. So this is the composer JSON file. Actually, it would be like the one for exercise 3. The only difference would be the name for the package. So let's then commit to Git. So as I was saying, every time that we want to commit to Git, we want to specify a version for that. So I am just going to copy from here. I'm going to git add everything. Then I'm going to git commit the message, assign a tag, push to master, let's say the branch master to origin, and then push the tag. So I'm going to do that. Copy to here. So it's done. And since we have now the composer log file created here, we are going to add it to git ignore for this library. We already did composer install, so let's just add that to our git ignore file. Now it's time to create a change log file. You could create the changelog file any time, but obviously the earliest the better, because you need to have a way to provide for yourself the control. The changes that you are doing to your library and to provide them to others. So we are going to start by creating that file. I'm going to proceed to the next page, okay? You good? So let's create the changelog file. If you are following with the slides, you just can go to click on this to see how it is going to be looking. I am going to copy from there. So this is going to be the file. So it is going to be also in Markdown format. I am going to my editor and create that file. changelog.md, and I'm going to paste it. So this is what we can see. So we have the title of the changelog file. Then we are following a convention here for this changelog file. So we are putting all notable changes to this library will be documented in this file. The format is based on this resource, which is keepachangelog.com. Right now they are on version 1.0.0. So this is a changelog based on the convention of this site. You can specify here the versioning convention that you are following. In this case is semantic versioning. So you have the page, Zemver, the specification, and the version for that. And it is like, since changelog, it is going to be a difficult file to maintain because it has to be on each version, on each change of your project. There is this unreleased tag that you are going to have. So if you already know the features that you want to include in your library and you haven't started, you can like put them in advance in this unreleased section. So at least in the future you can just copy from there and paste on the version that you are releasing. And we are complying with the rules. Like for example, we have this version title 0.1.2, which is the one that we are going to commit in a few minutes. We are providing a date for that change. I copied this from the library that I prepared for this, so it has that date. So we are putting the sections like added. We added a changelog file. This is the only time that we are going to mention the changelog file, because it would be like very redundant to have that file on every changelog file, unless you are doing some fixes or whatever, right? But we are adding that changelog file. We changed the gitignore file to include the composer log, and we in this case I put this because that's the way I created the library. I just added more steps while I was advancing on that. But you would, in general, include any change that you have for that. So for version 1.1, what we did is we ran composer init. We created the composer JSON file. We added vendor directory to our gitignore file. We changed the README file. And in version 0.1.0, we added the README file. So this is the format that we would have for the changelog. I just saved it. And this is what I just described. So let's commit to Git. So it would be the same set of steps. We would add all of the changes that we did. And obviously this depends on the workflow that you have for your library. For example, right now I am not creating any branch and that because this is just an example, but it depends on the process that you have to follow for your library. So I am adding now version 0.1.2 with this message. I will push the branch master to the origin, and then I will push the version, the tag I mean. Let's paste this. Okay, so we are good. Okay, so I pushed to GitHub and now we can start preparing for development. So one of the practices that we want to have while we are developing our library is to include tests. So for that, we are going to follow this convention of PSR4 having our separation of our source and our test. So our source is going to be our functional library, and we are going to have the test just to make sure that the library works the way we expect. That's why we required PHP unit for this. So let's create those directories. So it is going to be source, SRC from source, and test in our library. So we will have them there now. And we would need to have more parameters to our composer JSON file. So we are going to add these parameters. We are going to have keywords. There we are providing a way to the users finding our library. So we are going to have, like, for example, the name of your company or your package or your Git user or any keyword for your library. Like if it is like a routing library, then you would include route keyword here. So I just put this, but you could put any keyword that you would like. Then the home page of your library, it could be a separate resource, or it could be hosted in GitHub pages also. We are going to talk about that later. Since we are going to start development, now we are going to require PHP code sniffer. So we are going to be complying with PSR2. Also, we will provide a way to our software to be auto-loaded. So we are going to provide the auto-load and auto-load dev keys complying with PSR4. So our library for the auto-load is going to be under source. So we are specifying conquerorsoft / well, in this case, I'm going to use my user. Conquerorsoft was for the repository that I uploaded. My first library, and then the source. Here, it is very important to have those double backslashes, and here too, so it can be taken good for the composer configuration. We are going to have the test in the test directory, and this is the section that I was talking about earlier, the scripts. We can define there like the commands that we want to run and what they are equivalent to. Like, for example, if we run composer test, it is going to run PHP unit. If we run composer check style, it is going to run PHP code sniffer with the PSR2 standard and all of these other parameters. If we want to run PHP code sniffer that fixes, which is CBF, we would add this fix style. So I think it would be easier if you copy for the file. So if you can go to the slides and just go to the copy link. And you can see all the sections. And there, what I'm going to do is I'm going to copy and adapt it to the way I have it, so I don't type everything again. So I am just going to replace this file. And since that was for the Conquerorsoft library, I'm going to put my GitHub user here instead. Gabriel Conqueror, my first library. And I need to replace the version for PHP unit, which was the latest in that case, but I'm going to put 5.7. What else? The constraints, I'm going to change these for carets instead of tildes, which is not that huge difference, but and finally I'm going to change this Conquerorsoft for Gabriel Conqueror. and Gabriel Conqueror. So I think we are good. Let me just see my notes. I changed Conqueror Soft to be Gabriel Conqueror. You would change by your user. PHP unit to be 5.7. Verify the PHP version constraints. I already did. And values in PSR4, which I changed to be Conqueror Soft instead of, Gabriel Conqueror instead of Conqueror Soft. So we are good. So okay. So everyone is in that step. Okay, so let's move on. Those are the sections that we added. For the test of our library, we would need to define. It is not like that way, the only way, but it is easier to define a PHP unit configuration file. So that is to let PHP unit the configuration that we want to have for our test. So in this case, you would do that by an XML file. We would define the bootstrap file that we would have. In this case, it is under vendor autoload. So this way, PHP unit script is going to be able to access all the library software that we have, the classes and everything in our code. It has other parameters that could be like up to you to define. We would have the test suite. In this case, I am just putting like Conqueror Soft, my first library test suite. The directory is going to be under test. The code that are going to test my libraries are going to be under test directory. What I want to test, the classes are going to be in source directory, which files PHP. And finally, I can generate reports based on the coverage, test, and everything that I want to be aware of in my library. So again, you can click just the link in the slides, copy from there, and I'm just going to create it here. New file. I'm going to paste this and replace this name by Gabriel Conqueror. Save it as PHP unit. So PHP unit.xml, I just copied there. Every time that we are going to have a PHP unit or a PHP code sniffer, it could like output results. In this case, we configured PHP unit to output results to build. So that's why we are going to add that directory to git ignore. After that, we can run composer validate for the sections that we just added, and then composer update, because now we have new requirements for our library. And we would commit to Git with a new version, preparation for development, version 0.13. We would push the branch and the tag. So let's do that. I'm just going to copy from here. So adding build to git ignore, then composer validate. Okay, for example, here, this is what I was saying, like one of the steps. If I just run to do composer install the composer update, it would say your log file is not up to date with the latest changes in composer JSON, which in this case is expected because we just changed the file. So what should we do to solve that? Composer update. So it is going to compare the files, that everything is going to be compliant and they are going to match. It is going to install everything that it is new to install, like in this case it is installing the PHP code sniffer, and the composer log file would be updated to that. So we did composer update. Now let's commit to Git. And let's just take a look at the repository, how it is right now. So as you can see, now we have the changelog file. It is presented in an HTML format. We have our tags from 10 to 11, 12, and 13, the ones that we just configured. And we have the PHP unit configuration file also. So since we have now, it means that now we can run on the terminal something like composer test is the script that we just defined, and it is going to run PHP unit. In this case, it is going to say that we don't have any code yet to be analyzed or tested, which is good and expected. And yes, I am not adding right now anything to the changelog because this is like a workshop session, but you have to remember that every time that you do a change the changelog file. And this was followed when I created the example, the repository that I provided earlier, but we are not doing this just because of the time, but you should do it every time. So we are going to add the license file. For this example, we are going to use MIT, so we can copy that from the link. And we are going to start our developing by defining the classes that we are going to use. In this case, this particular library is a very simple one. The only thing that it is going to do is when you provide a string, it is going to return a string by shifted characters. So if you provide, for example, ABC, it is going to return BCB. So it's a very simple library. We are going to create the code to test that library, and then we can then commit to our online repository. So if you click the link for the MIT license, I am just going to copy from there. The only thing that you would need to know is when you are using the MIT license, you would replace the year, your name, your information, and that's it. Everything else is just like a template that you can use for your library. So everything is just defined. So I'm just going to copy from there. The format is going to be MD, Markdown also. So I am going to create the file here, paste, and I'm going to name that as license.md. So we are going to have it there. I put it at this point because at this point is where I am going to start developing, but you could do it like on any early step. Even since the beginning, you could choose just to include your license and put it there. So we just created the license, and we can now start creating our code. So let's just start with the test. I'm sorry. So let's create this file under test, and I'm going to open NetBeans for this because it is easier for me. So new project, PHP with existing sources. I'm going to browse for that.
So this could be with any editor, but I am using this because it provides me with help with the auto completion and that. So I am not a master in Sublime yet. So we have our source files, we have the source and the test. We are going to create a new class under test. It is going to be, I think it was first class test. So first class test. And the namespace is going to be, I'm going to copy it from here, is going to be Gabriel Conqueror / the name of the library, in your case your GitHub user or your library. So I'm going to put this here. And yeah, so the only thing so far we are going to have defining the namespace. Gabriel Conqueror, it would be your name of your GitHub account, your first library, and the class that we are going to use for that. So this class, since we are testing, this is going to extend for PHP unit. So we are going to do extends test case, and that is going to be for PHP unit framework. So that way we can define our test for development here. What we are doing here is TDD. It doesn't mean that you have to do it that way exactly, but at least you should provide test like in a way to demonstrate that your library is doing what you expect it to do. So in this case, as I was saying, we are going to have a function that it is going to encode a string. So we are going to then create a function like public function, and we are going to name that test encode string ABC is B, C, D. So if we want to test that function, we need to say, okay, I'm going to have this variable, my first library is going to be a new class, first class, because we are testing first class test. And I'm going to say, okay, when I want, what I want to do is when I have that calling encode string function, if I provide ABC, I am going to assign this to a result. So I am going to say I want to assert same that result is going to be equal to B, C, D. So that's our first test. So now we can start using a composer test from our console. And it is going to say that we have an error. And I'm going to use PHP unit because it uses colors here, but it is the same. So it is saying that we have an error. First, we don't have a code yet to be tested. So it says incorrect whitelist config. No code coverage will be generated because we don't have anything yet. There was one error, which is we have this functionality, Gabriel Conqueror, my first library, first class test. This is the function where we are going to have the error. And the error is that there is no any first class found. So, and that's on line 20 of our test. So in order to fix this, we would then need to create our first class into our source directory. So let's just do that. New class. We are going to create, what is wrong? working. Well, in the time it reacts, let's go here, and I'm going to create a new file. I'm going to close this. So I'm going to copy from here just to have the same information. So it is going to be the same namespace, Gabriel Conqueror, my first library, but instead of first class test, it's going to be just first class. It is not going to extend from anything. So I am just going to save this as first class PHP. And let me try to open NetBeans again. And here I'm going to delete this function because we don't have anything yet defined. So now if I go to my console and do the PHP unit, I should have something different. It is not complaining about the first class any longer, but it is complaining about the function. We don't have any encode string method in our class. So that's the error that we have here. So let's just create that method. Public function encode string. And that's it. That should be enough to change the error here. So it changed. Now it says there was one failure. So we are still like in that dread phase. So it says failing asserting that BCD is identical to null because we are not returning anything in our function. So let's just return that in the function so it stopped complaining. So BCD. And we are good, our pass test. So this would be a very useful way to develop your application because you are providing a test for each function that you are developing. Obviously, this is not finished yet, right? Because I could say, okay, I have that that test. It is not reacting yet, so let me go here. I have this test that if I encode a string ABC, is going to return BCD. But what if I say, okay, that's good, but if I need to test another functionality, like a test that, like for example, NBB is going to be, so we have OCW, right? And then we can have the same test here. We are going to provide NBB, and we are expecting OCW. So if I test again, it is going to say that BCD, which was the previous value that we were having, is not going to be equal than the one that we expected, in this case, OCW. So what we would do in that case is develop the functionality to have that in our class. Like if we are going to encode the string, we would then have like a source string. Like that, we would accept these characters, and we would have a destination string having almost the same characters, but instead of starting with A, it would start with B, and it would end with A. So now we could have a for saying that we are going to start on 0. We are going to be going until the string length of string, which so far we haven't provided, so we need it here, string. So we are going to go character by character on this string, and then we are going to increase I. So we are going to return, we would need to provide like a result string, so let's put result is going to be to empty string, and we are going to use a position. Is going to be looking for particular the result. I mean, this is the haystack, so we are going to use the source, and we are going to use the character we have. I mean, we are going to use here string, the character in post I, and we are going to say result is going to be destination in I, right? And finally, instead of BCD, we would return result. So let's see if everything went good. So it says, this is another error, right? It says undefined variable res here, and that's on first class 26. So let's go 26 is not res, is res. It would be easy if I change this instead. Oh, and here is not I, is pos, right? Okay, let's see if everything goes good. And we are done with our development, right? So we have a string that returns for a given string some shifted by one string. So we are good. We provide that functionality. We have our test. So now we can proceed to the next steps. Any questions so far? Okay. So we would commit to Git. We would have that encode and decode functionality. What I'm going to do here is I am not going to do the commit as such and that. I am going to show you the finalized library instead, because the test would be like a huge list of validations. But from there, you could start like seeing these steps for your own library. So let me show you the version as it would be the final. So this is the one I had. So obviously, even when the functionality is very simple, I would need to have more tests. Like, for example, I am testing here. The functionality in this final example, final version is the same. The only difference that I have in this library against the one that we just developed is that in this case, the shift is by 9 instead of 1. And it was because it is easier for me to do the demo just by shifting 1. But here, for example, I am testing test encode string. Like in this case, I am calling the same functionality. I have the first class, which is going to be first class. The encoded string is going to be calling for that encode string method or of first class. We are going to provide the string, and we are going to assert that the result is going to be equal to what we expect. So we started testing one string, then we tested another just to make sure that everything is going to be working good. So in this case, it's the same function. We are just providing a different parameter, and we are expecting something different. And now we would add a decode function, not just encode, like a test, decode the string, and this string. So we have the functionality to add a decode string function. We provide this, a particular string, and we expect testing, which is the decode version of this. Then we would decode the string, another string, because we are following the TDD paradigm in this case. We would provide another string, and we would compare that against what we expect. But there are other cases, like for example, you can say, okay, what if I provide an empty string? What am I supposed to receive? Like in this case, we are defining the behavior of that library. That's why it is important to consider the test, because if I tell you, okay, we need a library that it is going to do this, you need to start wondering, okay, what happens if I provide a null string? Or is there any restriction to the string to be encoded? Like what if I provide 2 megabytes of a string? So that's why you should have the test, and that way you make sure that your library is supposed to work the same way that you are expected. So the same, decode with the string empty. Encode, what if I provide uppercase instead of lower cases? So then I would need to have a functionality that says, you know what, it doesn't matter if I provide a uppercase, I need it converted to lowercase. So you are defining the behavior of your library. Each function that you have here defines a behavior of expected behavior of your library. And again, this is like a very simple, but this should apply to your library in each step of the definition that you are going to do. Again, if I want to decode with uppercase instead, what if I provide a non-existent character, like a at or exclamation or any other character? What should I expect from the library? Like in this case, I would expect an exception saying as message having, please provide only numbers and alphabetical characters. And the same for the decoding. Like if I provide a character that it is not supposed to be there for the decoding, what if I want to provide encoding for numbers also? So I would say, okay, if I provide a number, I would have this, and the same for decoding. So as you were saying, as I was saying, this is just like a particular step that you would have under your development, and finally your class would behave according to those tests defined. Like for example, here basically is the same functionality. I am just adding like validations. Like for example, here we have the source, the destination. Before anything, I am converting to lower characters, and I have the position that it is going to look for that. But what if the position is false? I am going to return an exception. Otherwise, I'm going to return the string. And the decode string is going to be very similar. So in this case, I'm going to have this. So, okay, so I think we are good, right? So, but what about quality code? If I go to my library and I run composer check style, which is going to use PHP code sniffer, it thinks different. To me, it is like perfect, right? But PHP code sniffer is complaining. It is saying, okay, you have one space, expected one space after the for keyword, which is not there. You have, we have expected one space after the first semicolon of for, 0 found. So you have a rule, I mean a list of all the rules that you are not complying with. So then I can say, okay, so I have this on first class, line 23. Easy, let me go and fix it. So 23, it says that I should put a space here, right? So I save, and I check style again, and we don't have that any longer. But this list is just like 4 elements. Your code or your library could have like hundreds of them. So what you could do is, instead of just check style, like fix style. And even when it returns that red legend, don't worry, it just worked. It is not going to break your library or anything. If I go here, then I'm going to see that there is one space. It is visible, right? You can see it. There is one space here where it wasn't before. Here, so now all the code is complying with all the PSR rules for that recommendation. 1 second here. So what else? Okay, we already see PHP code sniffer. I don't know why it is so slow. So another important thing for your library is to add these what is called doc blocks to everything that you need to be considered by your functionality. And this is just a way to let know the consumers of your library what you are going to expect on each step of your classes, your functions, or your variables that you want to define there. So, for example, the block log would consist on this format. You would have /**, then you would have a summary, which is like expected. You would have the description, which is optional. It is after one line, so you would have the summary, one line, and the description, one line, and then tags for all the code that you are defining. This is important because there are tools like a PHP documenter that can scan your code, go through all of these doc blocks in your code, and generate a documentation for your library. Obviously, this documentation is just going to be for the API part. It is not going to be like a, let's say, a human-oriented library. If you want to see which function does what, you would go to the API documentation. So that is important. If we go to the code, the final version that I was showing, you are going to see those blocks everywhere. Like, for example, here we are defining the first class file. Whenever you have a file, you can add this doc block that applies to the file, not to the class yet. So you can have these like the license or the package, the author, the copyright, and any other information that you need to display here. Obviously, you can define like human readable information, like just file containing first class, and add that as explanatory as you want it to be. Then this would apply for the class, like this class provides functionality, and you can define what is your class expected to do, the author, or whatever information that you want to do. In the case of the functions, you would define what the function does. Like in this case, since the description is optional, I am not putting that, but I am putting the summary and the tags for the doc block. In this case, I am saying, okay, this function is expected to have a parameter string type, which is going to be $string. It is going to return a type string, but it can throw exceptions under certain conditions. So you are defining all of that for all the functions and all the functionality in your library. So that's very important. We would add that to the library, and this is what I just did for the example that I was providing earlier. So you can go and see what exactly was done and that in the GitHub repository. And once you have all of that, then it's time to integrate some continuous integration tools into your library. So the way you would do as we saw before is you would add the repository to Travis continuous integration, you would need to have a Travis configuration file to tell Travis what to do and how to do it. So this is the file, how it would look. I'm going to open that in the link. So you provide a configuration to Travis. So I can say, for example, okay, I want builds for these versions of PHP. This is going to be triggered whenever you do a push to your repository. I can configure the cache for that. I can say, okay, include PHP 5.6 with these environment variables, because this way I can test, like, for example, if I want my library to, if I want to know if my library is going to work with the distribution version of it, like ignoring any file that I have there, or if I want just stable versions, or if I prefer the lowest version. In theory, if I am requiring a library and I provide a preferred lowest or preferred distribution, it should work for all the available versions for the library that I am needing in my own library. So I can say, okay, do the composer update after that. I don't want interaction. I prefer distribution. I can use the scripts that I have, in this case, PHP code sniffer. So I can automate the revisions for the code there. I also can use PHP unit to show the coverage of my code with test. So I can generate that so it can be used later to show that information to the consumers of the library. And I also can provide like any after script, like for example in this case, since we are using a Scrutinizer 2, every time that we generate a report for coverage, we are going to send that report to Scrutinizer. So that's the after script. Once the build ends, we are going to send that to Scrutinizer so we can display that information in our repository. So this is how it would do. You would create a Travis account, continuous integration account. It would ask for authorization for your users. So it is going to tell you all the specific information that Travis needs in order to run with your library. You can even specify the organization access that you want to grant to Travis. So in this case, I have these two. After that, you would have that completed in Travis, and then you can select the repositories from there. Like, for example, here, you would have the organizations in this case and the library. You would turn this to enable. You already have the Travis YML file. And after you push that, then you are going to have your first build with a Git push. So on your GitHub account, you would have that added as integration service, where you are going to have that listed because it already connected to your GitHub account. So after the first push that you do, it is going to start immediately to show you the stats about the build. Like, for example, in this case, it failed because I think I put the version of PHP unit to be the latest, and it was not compatible with 5.6. For example, here, the one for PHP 7 passed, 7.1 passed, but the others didn't pass. So I fixed that. As I was saying, every time that you do a push, it is going to load this in progress build, so you can see exactly what is happening. And one thing I want to show you before moving on is that it is not, it doesn't tell you only it failed and that's it. It shows you where it fails. Like for example, if I go to the library that was used for this, I can go to my first library, build history, and I can go to the specific version that failed. Like, for example, I'm going to this one. and I see the error here, so I can go to 5.6, and then it's going to show you this saying exactly where it failed. Like, for example, your requirement could not be resolved to an installable set of packages. Like in this case, for example, here it is trying to install PHP latest version at that time, say 6.4.3, and that requires PHP 7, but we have PHP 5.6. I mean 5.631. So you can know exactly where it's happening and how to solve that. So what I did is I changed the versioning constraint for that. I pushed, and this time it was built for all the PHP versions that I was concerned for my library. Like if I want to do a library that it is still compatible with 5.6, then I can make sure that this way is compatible with that version. Even when it is just the test, but it could be for any other library. So that's why it is good to have these kind of tools. So for example, here, the batch was still with build error, and this batch could be used to show it in your README. But after that, it was passed, then it was converted to build passing. And since we are having that, for example, in this case, this is what I was just mentioning. I changed the PHP unit to be this version. I committed and everything to add support to PHP 5.6. I committed, and on each commit, I provide the version. I push both the branch and the tag. And as I was saying, once you have Travis continuous integration tool, then you have the ability to grab that batch. You would go to the Travis configuration in this case. Let me go there. And if you click the build passing, you can go and say, okay, I want it for branch master. I want it in markdown format. So you can copy that from there and then paste it in your README file. So basically it's the same window. And also you can have the license batch in your README repository. For this I used IMG Shields IO, which already has a batch for MIT license. So I just copy it from there, and now it looks like a nicer, right? For me, this step was like a no man. I don't know if my library works, but I have batches in my README. So we can start integrating the batches that are provided by these continuous integration tools, right? So now we have that for Travis. And we would do a very similar process for Scrutinizer. So it would be like with the Scrutinizer account, we would have a different file because this time is a different continuous integration tool, but we have the same configuration option. Like, for example, you can say, okay, excluded paths test, because we already are considering, they are already considered in another tool. We can say, okay, check for PHP if we have remove extra empty lines, true. Remove PHP closing tags for PHP files, true. So we define a rule, a set of rules to be followed on the code quality for Scrutinizer. Some of them can be like not belonging to PSR 2, but we can have them there if we want to. And finally, we would say, okay, besides that, we are going to have a external code coverage. In this case, this is going to be provided by Travis. So it is a very similar process. We would link our GitHub or Bitbucket account to Scrutinizer. It would ask permission to your account and certain information from there. You would complete your account, like the first name, last name, email, and all of that. You can specify like at organization access, like for example here it was not granted, and I granted later, so because the repository lied on that organization access. And then after that you would select your repository, like in this case the one that I had is Conqueror solved my first library. The default configuration, should Scrutinizer run your test? Yes. And it doesn't mean that it is going to be ignored like we said in the other configuration file. It is just going to run them as a way to have that build process in that build step, process step in the set of steps that it configures. So as soon as you configure it, it is going to trigger a inspection. It is going to go through your code. According to the configuration, it's going to compare everything. One thing that I like about Scrutinizer is that it can detect like security vulnerabilities. Also, like for example, if you are not escaping something, or if you are like skipping a sanitization, then it is going to let you know about that. It is going to be configured in your GitHub account as webhook also. Well, it's different, integration services and webhooks, but the goal is the same. It is every time that you do a push, it is going to trigger a build on Scrutinizer. So here, for example, this was the first inspection. It taught me that the test coverage, no, this is the second actually. The test coverage was 91, then I had to go and fix it to have it at 100%. One important thing about this is it doesn't mean that you have to be 100% coverage all the time. The standard minimum is 80%. So if you have 80% of your code coverage, that's good. And in some cases, it is like impossible to have 100%. In this case, the library was like a very simple, so that's why. But it also provides anything that it found. Like for example, in this case, it is saying one new patch because it is related to spacing, so you can apply that patch related to, in this case, code quality. But as I was saying, it can provide other information that it is more useful than just spaces. So you can go to the patch, copy the URL using curl that they provide, and then you can apply that patch in your code and go and do your build. Scrutinizer is going to give you also these batches. Sorry. So it is going to display, like for example, the grade that you have for your code quality. In this case, it is going to be a scale 0 to 10. The coverage of your test, and if the build passed. So you can go to each of those batches that are provided by Scrutinizer, just copy. They have several formats, like the image URL, Markdown, or any of these. I just copied the Markdown for those. I didn't copy this because I already had the one for Travis, so I just copied these two. And then I can include them in the Git, build, and push. And now I have more batches. Like when people go to my repository, they are going to say, oh, okay, yes, at least it has 4 batches, it should be good, right? Obviously, it is not that good if your build doesn't pass, right? Or if you are having a coverage or 15% or something. You are targeting to have like a good coverage, good code quality, that your build pass. So here, for example, I did a build and I was introducing some type hinting for PHP 7, which was not compatible for PHP 5.6. I applied the patch for Scrutinizer. And another important thing about this is if you want to open your library to contributors, you need to have a contributing and a code of conduct links. They are like open to any specification that you want to set as a rule. Like for example, here this is not following any particular standard. I just get this from a repository which is suggesting to include this. And those links are in the last slide, as I was saying. So you would have the rules that you want to define. Like, for example, in this case, I am accepting contributions. So they are welcome. They are going to be fully credited. We are going to accept them via pull request. We are following these standards, add test, or otherwise they are not going to be considered, etc. So we have that. They should include the composer test in order to have those accepted. And for the code of conduct, this is based on a standard, but you can follow any standard, really. This is based on the contributor covenant version 1.4, and you have to put this attribution. But it says basically how you are going to contribute to this particular library or software. It specifies the standards, the responsibilities, the scope, enforcement, and everything. So that's something to consider when you are creating your library, and if it is going to be open source, you should think about this. Other sections of your README file is like install, usage, change log, testing, contributing, security, credits, license. You need to provide those for those that are going to be using your libraries, where to find the change log, how are you testing your library, the rules for contribution, etc. What I did. Sorry. I put those in GitHub. Another important thing, I'm sorry if I am going too fast, but we have 10 minutes. It's the Git attributes file. This file would have like all the files that your library doesn't need to work. Like, for example, the documentations, the test. Even when some persons may got your library, maybe they don't want your test in the production environment. For example, if they are going to use your library in a production environment, they would need your test. So in Git attributes, you would define all the directories or resources that you don't want to include if they prefer to install your library from distribution. Like in this case, we have the same file, Git attributes, Git ignore, the ones for the continuous integration, for the test. If we have any test or documentation, we don't want them to be on production environment of other people, because that's just a space, wasted space. So now, we already did this, but how can we let the world know about our library? So for that, we would create an account on packages.org. We would submit our library to there. We want to make sure that our library is going to be auto-updated, because since we are not having by default a process linking GitHub to packages the same way for the continuous integration tools, we need to define that manually. And after that, guess what? Another batch to our README file, so we are progressing. So we would submit our library. We would provide the repository here. It is going to do an analysis and say, okay, we have this repository. It's going to be like conquerors of my library. Yes. So we would have this. As I was saying, your package has not been crawled yet. Some information is missing. Your package is not auto-updated. So that process is going to be asking for that. Okay, it was fetched, but it is not auto-updated yet. So we need to do something with that. We need to go to GitHub account, add this integration service for packages. We would provide our token from packages, and then now every time that we push is going to be updated in packages. So these are all the versions that we had so far at that point. It is saying all the information that we had. The README file is going to be displayed there, and now we have the packages batch there showing our last version in packages. So we would include that in the README file. And now the documentation for humans, like we want to know persons what our library does. In order to do that, we could do this. We would create a gh-pages branch in order for our documentation to be there. It could be on the master branch also, and it would take the information from the README file, but it would be up to you how you want to handle that. I think it is good to have it in a separate branch if you want to do anything with the documentation and just don't want to have that affecting your master branch. So you would go to GitHub, and you would have this source. The source is going to be the branch GH. You would choose a theme for that. As I was saying here, GH pages branch. You would change the theme. And now your library would be good to be seen there. Like you would have something like this. They have like 10 different themes. I just chose this. But then it has like a more friendly interface where you can go and see. This is the library that I created for the interface. So you are going to see everything that we did here. It is going to be here in this README file. So you have both the slides and the README file for the library. So it's going to be a better look. And yeah, that's it. So exercise 4, creating my first project using my first library. We already finished with our library. We are good. So what we would do, and I think I just will go through the slides because of the time, but you can do it later if you want. It is not that complicated. The steps are just basically the same. We would just create my first project. We would create the README file. We would go through the same process of adding that README file, the change log, handling the versions, then include that in GitHub. We would create our composer JSON file. The only difference that you should see is the type is going to be project instead of library. This is our composer file. We would have the same initial template. And then we would need to add our library. So there are some important things here. If we want our library to reside in our file system or in our network, we would use the repositories key, and the require would be just specifying the version of our library. In this case, Conqueror Soft, my first library. Where to find it? In version control system in this URL. So if I run Composer install, it is going to go to my file system, and it is going to get the repository from there because it is a Git repository from version control system. We would add the changelog file, which is going to be very similar. And then we would start the enriching the composer file. In this case, we are adding the same scripts that we had. If we have any homepage for the repository, the keywords, since we are going to upload that to PHP, packages, we would create the PHP unit file and prepare for development, add license, and we would add the test for our classes and the class that we are going to use. And it is important to have that composer autoload key defined there also. So in this case, we are not talking about our library, we are talking about our project. So the source is going to be under Conqueror Soft, my first project. The test is going to be under Conqueror Soft, my first project. Then we can use composer dump autoload to have those created. We would integrate Travis and Scrutinizer also. And this is one important step so you can consider. So we specified in Composer that our destination for the library was going to be in the file system, but you also can specify the URL for that version control system. In this case, it is going to be not a file system URL, but an HTTPS URL. If you provide it this way, you need to provide a way to access from the project to access the library. So we would link to Scrutinizer also, and we can release our first version. Actually, I didn't talk about that. You are going to migrate to version 1.0.0 once you are ready with test and all the information that you have, and your library is completely functional, since version 0 point whatever is not considered stable. So you would move to version 1.0.0 whenever you are ready and confident that your library is going to be used. We would submit the package the same way we did for the library, but in this case it would be for project. So we would have the same steps there. We would link the GitHub account. We would include the batch for packages, and the documentation would look very similar. We would create the GitHub branch in order to show the documentation. And that's it. So I am just going to show you quickly the project code. This is almost the final slide. So let me go to here. My first library, my first project. So here in the composer we have the requirement for our library. In this case, require composer my first library, minimum version 1, and the class would just call ConquerorSoft my first library first class, and it would use in the encoding function. So I can say now, okay, my first library is going to be first class. I need to encode this string, and it is going to be returning a result. The string provided is encoded as encoded. The same for decoding. So if I go to the terminal, I'm just finish up here. I'm sorry if this is taking time from the lunch. So PHP library. So I go to my first project and I go to source. Now I can show how this would work. Like I can say include vendor autoload. Then I want to create a new instance for first project class, which is not the library. And then I want to run the encoding function for there. And I can say, okay, run in the project the encoding function test string, and it returns the string. Test string is encoded as this. Or I could say decoding this, and it decodes that to test string. So this is calling the project, and the project is using the library. So that's it. So any questions? I use both because let's say that Travis is providing the part for the building and the step for testing, and in the case of Scrutinizer, for example, code quality is not included in Travis. So Scrutinizer is going to provide that code quality qualification, but it provides the build. So let's say they intersect in the build only. So Travis provides information, does the steps. Both of them can also include steps to deploy to production or to any environment that you configure to. And Scrutinizer is providing what Travis doesn't provide, which is the code quality, and basically those would be the main differences. So any other question? Okay, please remember to go to the repositories. All the steps are there. And don't forget to rate the talk and give me feedback. after you have your lunch, so you are not angry with that. Don't say I missed my lunch. And you have a list of resources here. All of them are like very valuable. I would recommend to go to each one of those, and you are going to find like a lot of information there. So, thank you.